If you remember, we talked about triangle method. Let's solve another one, another example of triangle method. For example, this is our triangle A, B, C, with the angle of 60 here. A is 5, B is 6, and I want to find C in this case. If you have such a situation, for example, you have a force like this, and you have another force like this, A, B, and you should find C. Because you have two edges and one angle, so you should use cosine rule. If you remember, I told you when when you want to use cosine rule, you have to follow this equation. This angle is C. So in here, let's find it. A is 5, so 5 square. B is 6, 6 square minus 2 is 5. Let me make this, because it's not working, let me make this 2. Okay, 2 over 2, 4. Minus 2 dot 5 dot 2 dot cosine of 60. It's equal to 29 minus 2 dot 5, 10, 10 dot 2, 20, 20 dot cosine of 60 is 0.5. So it's 10. That would be 19. So C squared is equal to 19, and C is this. About, for example, 4.5, something like this. Okay, so you can see that if we are in this situation, we can use cosine rule. In the other case, sine rule, for example, we have another situation. In this situation, we have this angle of 30, this angle of, for example, 25, and this one is, for example, 5, this one is 6, and we don't know how much this is. Okay, so in this case, or this one is also unknown. A is 5, B is unknown, B is unknown, and C is unknown. How much is this? You all know that A plus B plus C is 180, and In this case, 180 minus 30 minus 25 would be what? So this is the angle C. Okay, I need to find this edge. So sine of A over A is equal to sine of B over B. How much is this? Sine of A is, so sine of 30 over 5 is equal to sine of 25 over B. So we can easily find B. B is 5 dot sine of 25 divided by sine of 30. The answer is 4.22. Okay, so this is the application of sine rule. In here we use sine rule, and here we use cosine. If I ask you how much is C, what would you do? To find C, we can use this equation, sine of A divided by its front edge, this one, A equal to sine of C divided by its front edge, C. So sine of 30 divided by 5 divided by equal to sine of 125 divided by C. Okay, C is equal to 5 dot sine of 125 divided by sine of 30. It is equal to 5 dot 0.82 divided by 0.5 equal to 8.2. Okay, so this is the application of sine. Okay, I'm not gonna continue this method anymore because the most important method that you're gonna use it in future is the calculation of or defining the component of forces. So far, we talked about parallelogram, triangle method, and the third one method. In the third method, we find, or you can say, component method. In the component method, This is the force, starts from point O and in, for example, XY system, XY coordinate. And you have another force like this, one force like this, the other force like this. If I ask you to find the summation of the forces, using, for example, triangle method, using uh, parallelogram method, because you can see that first of all the forces are the number of the forces are more than two. So if you want to perform the previous method, if you want to use the previous method, you should do it several times. And also, for example, for triangle method, sometimes you need complicated calculations. So the easiest method is the component method. How? First, before we start with the method, I have to explain something. Suppose that we have a force like this. F. The component of force F, or we can write the force F like this. Fx I plus Fy j. What does it mean? It means you can dissolve, you can decomponent any forces, any vectors like this. This is axis x, and this one is axis y. The component of the force F that is along the axis x would be Fx, and the component of the force y that is and the component of the force that is along the axis y would be Fy. Okay. So how can we find Fx and Fy? I'm sure that you know it. How? Suppose that we have angle theta here and another angle alpha. Theta plus alpha is 90. Okay. In a triangle like this, A, B, C, with the angle of theta. Let me ask someone uh, who is here, Abbas Ali. Do you hear me?
Yes, teacher.
In this case, could you please tell me what is the sine of theta in this triangle? Sinus of angle theta. When we want to find the sinus is B divided by C. What about cosine? A divided by C. So What is A now? Is equal to C dot cosine of theta. And in here, B is C dot sine of theta. Okay, so we can use this rule, these equations, to find fx and fy. You all know that in the coordinates system, in here we have a 90-degree angle. So this dashed line is parallel to this coordinate. This dash line is parallel to this coordinate. So this angle is 90 as well. In this triangle, let me highlight this triangle. In this triangle, if I ask you what, so this one is parallel, so this one is fy2, and this one is parallel, this dashed line is parallel to this one, so this one is fx2. Now, I want to talk about this highlighted triangle. So, in this triangle, if this is our force F, let me write F here. In this triangle, if I ask you what is sine of theta, you would say Fy divided by F. And if I ask you what is cosine of theta, you'd say Fx divided by F. So if I ask you what is Fy, you can say that is F dot sine of theta, and in this case you can say that Fx is F dot cosine of theta. Now let me ask another one. Abdullah Tariq, you hear me? Zainab.
Yes, teacher.
In this triangle that I highlighted, could you please tell me what is Fx? Here we have, instead of theta, we have alpha. Okay, I want to talk about this triangle. I want to know what is Fx. Okay, what is sine of alpha? Can you say sine of alpha?
No, teacher, I'm sorry. I don't remember.
Okay, sine is equal to the front divided by this line, the biggest one. Sine of alpha is equal to fx divided by f. And cosine is equal to this one divided by this one. So cosine of alpha is fy divided by f. So Fy is f dot cosine of alpha, and Fx is f sine of alpha. Okay, so in this case, Fx is f sine of alpha, and Fy is f cosine of alpha. Okay, why should we know this uh, system, this process? In more complicated cases like this, when we have more than two forces, as I said, using the previous methods may not be applicable. So in these cases, if I want to find the final summation of this system, I need to find the component of each force like this. For example, this is F1x, this is F2x, this sorry F1y, this is F2x, this is F2y. Here we have F3y, and again we have F3x. For each case, we should find its components. And what would be the final summation? In the final summation, we have R, and R has Rx and Ry component. This is the summation. If you remember, this is the resultant, the final summation. Resultant. What is Rx? Rx is sigma f I x, and Ry is sigma f I y. What does it mean? It means f1x plus f2x plus f3x plus f4x would be Rx or Fx. Ry would be f1y plus f2y plus f3y plus f4y. That would be the final Fy. So the total F is for the total R. You all know it from Tigris rule in this equation. A, A, B, C. What is C? A squared plus B squared square root. Okay, so the final answer would be this. Let's solve an example to make this clear. F1. This is a force, or let me make this a real example. Suppose that you have bolt like this. Okay, this is a bolt. Let me show it in your book. or like this. Okay, suppose that you have bolt like this. Okay, this bolt, okay, is subjected to three forces. How, for example, you have cables like this: one cable, two cable, and three cable. And all of them, all these cables are pulling this bolt out. Okay, so you want to see how is the situation. To find this, uh, if you can, for example, the capacity or the resistance of this bolt is, I don't know, for example, 100 pound is the capacity. If you increase the force more than its capacity, this will be broken. So so you have to be careful. You should not increase the force more than 100 pound. So you have to find this final resultant of all these forces and then check if the resultant of these forces are more than 100 pound or less than 100 pound. Anyway, in all these procedures, first of all, you have to find the capacity. Sorry, you have to find the resultant. Before solving any example from now on in engineering mechanics, in strength of material, if you are a civil engineering student, if you are any in all in your uh, future courses, the first step is to draw free body diagram. We called it FBD. What is free body diagram? Because you can see that in all the cases we work with vectors and coordinate system, not with this bolt, okay, not with this clamp. We work with vectors, angles, forces, but so you have to convert these forces, this system, this shape into this shape, for example. Okay, converting of this shape into vectors and coordinates and angles and numbers is called finding free body diagram. So let's first find free body diagram of this system. In here, I have a coordinate like this, x and y. You have to find the you have to find the intersecting point or the intersection of these forces. The point at which all these vectors reach or meet each other. Okay, you can see that if I continue this vector, this direction, and this direction, and this direction, all these forces meet each other at this point. I call it O. Okay, so in this case, I have point O in the center of my coordinates. Now I'm finding free body diagram. The first force is this one. I'm going to call it F1. The second force is this one. I'm going to call it F2. And the third one is this one, F3. So this is F1. Let's This is F1. This is F2. And this one is F3. You have a couple of choices here. First, let me write their magnitude and their direction. This one is 60 pound. The other one is 40 pound. The third one is 50 pound. The angle of this one, alpha, is 25. This one, 60. And the other one is 50. Okay, in your exam, if you write this one, you'll get 50% of your mark. Okay, because this one is the most important part of your solution. So let's talk about the rest of this example. If you remember, I told you you can use triangle or parallelogram, but you can see that using a triangle method, it's not easy. It's not easy here. So at the first step, I'm gonna convert the forces into their component. So for F1, this is F1. F1 is 60 pound and the angle is 25. We'll have F1x and F1y. What is F1x? This angle is 25. F1x is near the edge, near this angle. I'll call it near and far. Okay, this is F1y. As I said, these are parallels and they are equal. So F1 is near this angle and Fx is near the angle and Fy is far from the angle. So F1, when you have a side, when you have uh, your vector near the angle, you should use cosine. So F1x is F1 cosine of alpha. That would be 60 dot cosine of 25. F1y. Y is far from this angle. You can see that this one is near, this one is far. F1 dot sine of alpha. That would be 60 dot sine of 25. Okay, we're done with F1. Let's go for F2. I'm gonna the components F2. For F2, this is the force. Sixty. In this one we have F2x and F2y. F2x is equal to F2, this is F2, dot what? Near cosine of 60, and f2y is f2 dot what? Sine of 60. You can see that this one is what? Sine of 60. So that would be 40 dot cosine of 60, 40 dot sine of 60. Let's go for f3. For the third case, the angle f3. Again, I'm going to decomponent it. This is f3x, and this is f3y, and this is f3. What is f3x? In here, look at here. This is f3x, and this is f3y. So f3x, you can see here that is far. It's in front of the angle, not beside the angle. So f3x is f3 dot sine of 50, and f3y is f3 cosine of 50. It is equal to 50 dot sine of 50. It is equal to 50 dot cosine of 50. Let's find each of these forces. In the first one, we have 60 dot cosine of 25. We have 54. In here, we have 60 dot sine of 25. We'll have 25. For this one, we have 40 dot cosine of 60. 40 dot sine of 60. All of them are in pound. And for the last one, we have 50 dot sine of 50. This one is 50 dot cosine of 50. 32 pounds. Okay, now we can now find the total summation. But before that, I want to tell you something about the difference between this force F, for example, 1x and F3x. You all know that the positive direction of the coordinate system is this one and this one. So in here we have x positive, in here we have y positive. In here we have y negative, in here we have x negative. So when we got F3x equal to 38 pounds, you should know that, you should notice that this force is negative because it's in opposite direction. But when you got 54 for F1x, you have to know that this is along the positive direction. So when I want to find the total summation, as I said, I need to find sigma fx. What does it mean? F1x plus F2x plus F3x. So that would be F1x Look at here, f1x is 54. Positive or negative? Positive, because it's aligned the positive direction. The second one is f2x, 20, and it's along the positive direction. Look at the red one. So plus 20. The last one, f3x. Can you see it? It's in negative direction, or negative x. So I should use negative sign here. Minus 38 pound. That would be what? 74 minus 38. Pound. Let's do it for y direction. That would be f1y plus f2y plus f3y. In this case, f1y is positive and its magnitude is 25. So we have positive 25. In this case, you can see that f2y is in negative, along negative direction. So the sign is negative 38, 34. And in the last case, you can see that f3y here again is in negative direction. And its magnitude is 32. What would be the last one? What would be the last answer? It's minus 41 pound. Okay. So if I ask you to find the total summation or R, as I said, this is, for example, fx, this is fy. R is equal to fx squared plus fy squared square root. So this is 36 squared plus negative 41 square root. The answer is 36 plus 41, 36 squared plus. The square root of 54. The answer is 54 pound. If you remember, I told you each force, each vector, each vector has both magnitude and direction. The magnitude of the force is here, 54. What is its direction? What is the direction of the so uh, what is the direction of this shape? The final one. I don't know if you know it, but for example, in this triangle, A and B, this is C. The magnitude of the force C is 54. What is the theta? We have two choices. One of them is when we have B and A, tangent of theta or alpha is equal to A divided by B. And what is theta or what is alpha? Arctangent or tangent inverse of A over B. So in our case, we know that this is the final force of all 6 components. we have a force in positive. This is our Fx. You can see it here, 36. This is our Fx, and this is our Fy. Negative 41. So if I ask you to find the final force, you can say that this is the final force, the red one, R. What is the magnitude? What the magnitude is? 54. Theta, tangent of theta is equal to this one, 41, divided by this one, 60, 36. Tangent of theta is 41 divided by 36. And the final angle is tangent inverse of 41 divided by 36. Okay? This is the theta, or the final direction. So instead of all these forces, I can show this bolt instead of all these complicated forces. I can show this force, this bolt, with just a simple single force like this, R. With what? With the direction of theta. What is theta? Tangent inverse of 41 divided by 36 or 34, I'm not sure. So you can see that here we have 1, 2, 3 angles, 1, 2, 3 forces. But in our case, in the final case, we have one force and one angle. So this one is easier to work. Any question? No?
No, teacher. Push.
Okay,
No, sir. No.
after all the classes, I'll upload the video of that session to YouTube, my YouTube channel. I'll again write the YouTube link, the video link, so you can, if you have any internet problem, you can again watch it on YouTube, because as far as I know, when one of my students said that it's easier to connect to YouTube than Microsoft in Azerbaijan because of the problem.
Thank you.
Yes, teacher. Microsoft is not open.
Okay,
Thank you.
so okay, see you later.
Yes, teacher.
Yeah.
Thank you. See you, teacher.
Yeah.